Thank you. Thank you. Good morning. I am Danilo Bisiach. I am a product manager for nuclear instrumentation at Instrumentation Technologies, and I will introduce our company. So we are a provider of diagnostic equipment for research, medical, and industrial particle accelerators. These are some kind of different machines compared to nuclear reactors, basically because they don't deal only with neutrons, but with electrons and protons. These particles are accelerated in this kind of big machines that they work 24 hours per day, 7 days on week. And basically, our instrumentation is measuring the position and the shape of these particles that travel at the speed of light inside these machines. We have also a second department at our company that deals more with industrial solutions, so, like valves, these kind of units, but basically just with the electronics. So, about our history, we are now on the market more than 25 years. Everything started in 1998 in Souken. Souken is a small city close to Gorica, Nova Gorica and Gorizia on the Italian border. And probably some of you can know that this city is also the hometown of the Nobel Prize Carlo Rubbia. He was born there, so a few kilometers away from our company. We are ISO certified, and also, why are we so long in this field of particle accelerators? So at the beginning, 20 years ago, everything was working with analog devices. So only analog electronics was used to control the particles inside these machines. And this required a lot of work also for scientists that were measuring everything with oscilloscopes. They were tuning it, calibrating it, and this somehow was even not stable for the machine operation. So our founder has had the intuition to switch from analog control system to digital control system. And this is where the field where we are now playing. What you see on the left, it's now just turned on the right. So we have one instrument, this is just one of the many that we produce, that it's fully connected to all the infrastructure inside the accelerator and can be controlled and tuned digitally. Here are some of our customers, and we can say that basically we work with all the labs in the world. You can see some big labs like CERN, ESRF, Soleil, ANL, but basically almost all the machines have at least one of our piece of equipment. If they don't have it, it's because they developed their own. And from the industrial side, we also collaborate with industrial companies that has the same needs. So measure fast signals inside industrial processes. So from the particle accelerators to the nuclear reactors, how everything started. We met a few years ago here at NENE with people from IJS and from CA. And we were presenting not NENE, but ANIMA conference. And we were presenting our instrument, the current meter, which is dedicated to low current measurements. And they had the idea to test it at their reactors with some in-core detectors. We tested it, it was successful, and this is where everything started. Because afterwards with CEA, we started a collaboration project because they developed an instrument that's dedicated to neutron flux measurement especially for in-core detectors. And they had the need to industrialize this device because you can develop it, but once everything works, you have to make a version of this instrument that it's capable to run for the next 10, 15 years. So it means to work everything with everything, like obsolescence, getting the right components, and so on. So we started this project and we validated the instrument in the last year. And afterwards, not strictly related to the world of neutron flux measurement, we started also to develop another device that's dedicated to the reverse osmosis plants. So SMRs are also considered as a side, as a side plant to this desalination units. And our device, it's a measuring device for salinity inside in the water. Where you have these big reactors, it can happen that one of the unit breaks, and you never know which unit it's breaking. So with this device, you have point-to-point, so reactor-to-reactor monitoring of how the unit is performing, and this leads to a quite high economic advantage. So what can we offer to the other stakeholders, to this community? We are probably one of the best companies on this for acquiring high speed and low amplitude signals. This means in the RF region, we can process these signals with DSP. Usually we use FPGA devices to do that in real time. And this is something quite important when you have to deal with real time process. And at the last, we are capable to integrate this device in control systems. So regarding our targets, we now have some knowledge about research reactor, nuclear research reactors, especially TRIGA, and we want to extend this knowledge also to the SMR reactors. And as we contributed to the change, to the transition from analog electronics in particle accelerators, we want somehow to contribute also to this transition in the SMR reactor field. Where do we see us? So basically we are one industry, and as well our developers are researchers, because mostly of our engineers are still researchers. They work in contact with people from accelerators. So we see our company like in the middle between these two elements. And about the stakeholders to whom we want to connect, for sure as well industry, research and education. This is what we do, for example, now with IJS and CA. We actively collaborate. For example, last week we had some testing there. It was a pleasure to see that our devices work also with other type of detectors that we were not expecting of. And okay, with SMR vendors, if there is any need to develop new kinds of instrumentation dedicated to neutron flux measurement, temperature measurement, everything what's related to digitizing high-speed signals, we are here to help. And that's, I think, from my